Can I start? Okay. Okay. I'm Reiji Suzuki at Nagoya University. Today, I would like to talk on how LLMs can evolve various personality traits within social dilemmas. This is the outline of this talk. Okay, so as you know, the modeling approaches to the evolution of social population often are based on the evolutionary game theory that uses mathematical and computational methods such as replicator dynamics and agent-based models. This is an example of the agent-based model showing the emergence and the collapse of the cooperative clusters. These kind of approaches has provided a general insight into the evolution of cooperation, such as the prisoner's dilemma in biological organisms and human society. But the conventional or typical model of the evolution of cooperative behavior typically describe the specific actions in particular situations as a direct representation of individual genotypes, like this. For example, this is a case of the deterministic strategy in the iterated prisoner's dilemma, showing that, for example, that this determines that according to the previous history of the gameplay, so DD, and this strategy determines that for DD case, it plays defection. However, this kind of behavior often stems from the higher order psychological or cognitive traits, including intention, personality, and preferences. But it is not easy to translate this kind of higher order trait into the specific behavior pattern in a different or diverse social context. That is very challenging, especially in the mathematical and computational models. Recently, there are a bunch of related research using large language models. For example, the machine psychology focuses on the effects of persona or prompts on the big five personality traits of large language model agents, and also the behavior of the large LLMs in game theoretical situations has been discussed. And also, the LLMs has been recently combined with evolutionary computation, such as incorporating LLMs into the evolutionary operators, such as a crossover or mutations. And also, there's a bunch of emerging studies on the LLM-based multi-agent systems, focusing on the world simulation, cultural evolution, and also collective problem solving. So by making use of this kind of findings and techniques, we can deal with and evolve complex personality traits in computational models by using LLMs. So the purpose of this presentation is to show an evolutionary model of personality traits related to cooperative behavior using a large language model. Actually, this model applies the capability of LLMs to output the behavioral strategy in response to the linguistic description of personality. And also, we use LLMs to mutate this existing personality description. So this is actually the minimum use of the large language model in the computation agent-based model, but this demonstrates how complex personality traits emerges through the course of evolution of cooperative behaviors. Okay, let me explain the model. We assume any agent, this is a simulated human individuals, and each agent has a personality trait gene described in approximately 10 words that determines its personality. For example, in this case, each one agent has this personality, so open to team effort, but self-interest frequently overrides collective goals. This verbal description is a genotype of this agent. Okay. And then this agent also has a behavioral trait. This is a deterministic strategy of the iterative presence dilemma game, like this. The question is, how can we map this verbal description to this behavior pattern? Okay. So for this case, we use the open source version of the large language model. Actually, this is the prompt we used to map from this to this. So this prompt comprises of several components. The first component assume that the personality of the large language model is like this. And then this part explains the game theoretical situation. So there's a two options, A and B, in the context of a Prisoner's dilemma. And then ask this element, then assume that if the previous actions are, for example, BB and BA, this is a mutual defection and successful defection. If the history is like this, how do you choose? We ask this kind of question to the LLM. And then LLM replies, for example, I choose strategy B, for example. B means a defection. So for this history, this behavior trait becomes D. I ask this question for possible combination of the previous history, and then we get this behavioral pattern. Okay. We conducted this process for all agents and get the behavior trait. And then fitness is based on the average payoff in the round robin tournament, and based on the Prisoner's dilemma payoff. And the evolution process is based on the selection. This is very simple. Upstream is stochastically reproduced in proportion to the agent fitness. And also the mutation process occurs with a small probability. But for this case, we asked the LLM to modify the original genotype to slightly cooperate or defective description like this. So this is a case of the cooperative, toward cooperative tendencies like this. So a little bit cooperative actually. So we conducted the evolution process through the 1,000th generation. Okay. Okay, so first, let me introduce the example trial. This figure shows the transition of the average and the dominant genotypes on a 2D plane. Actually, for each generation, there are 30 populations, so the 30 personality trait gene description. We mapped these description to the high dimensional vector using a sentence transformer, and then also dimension reduced to the 2D space. And this large circle means that the average of that vector, so position of the genetic description on the space. And this text represents a dominant genotypic description of a personality trait gene. So as you see that, so on this space, population sometimes stuck and sometimes moves around on the space. So let me explain a little more about the evolutionary process. So first, starting from here, and the population evolved toward the selfish personality traits from here to here, and gets stuck for a while. Actually, the dominant genotype is like this. So pursues personal gain consistently, neglecting mutual or group benefit entirely. So very extremely selfish personality trait dominate the population. And then after a while, the population evolved to be a bit cooperative and dominated by a more cooperative trait. So such as they prioritize collective achievement, personal growth ensures. Then the population moved and wandered around here, showing the instability of the cooperative relationship in the population. But after that, the population evolved to the most cooperative situation. And in this situation, dominant gene is like this, thrives in teamwork, prioritizing shared growth and success. So strongly focusing on the teamwork. But such a too much cooperative population is easily invaded by defectors. Actually, the intrusion of the personality traits of almost all defection lets the population from here to here. Okay. Okay, so actually the agents are playing the C or D repeatedly and evolved, but behind that, this kind of a wide variety of personality trait evolved. This is the point. Okay, then we conducted several trials to see how the evolutionary trajectory becomes on this space. Each line corresponds to the each trial, and color corresponds to the trial number. I will, because of the limitation of time, I will skip the detail, but if we compare the control experiment using the genotype that directly encodes the behavior traits, for example, like this, so 0 corresponds to defection and 1 corresponds to cooperation. Comparing with this case, population tend to show the increased stagnation in the defection-dominated states with the occasional emergence of cooperative behaviors, as explained in this slide. So this is typical behavior. And finally, we conducted, so we analyzed the effects of emerging words on individual behavior through the course of evolution of 15 trials. As this table shows, the top 5 words contributed to each behavior category. Behavior category means the proportion of cooperation and also the mutual defection and successful defection, being defected, mutual cooperation, and also fitness. So, for example, this part represents that the agent whose personality trait gene included gentry had an average cooperation rate of almost 80% in all rounds. So this part shows that the gentry fosters and harmony, this kind of generous word made the agent to choose cooperative behavior. But on the other hand, for the word tampering, trumps, disregard, brutal, this kind of word tended to make the game results, make the mutual defection. On the other hand, but the word skepticism makes the agent to have successful defection. But the too much general words, such as good and gently or unwavering, this kind of word might be too much cooperative, that resulted in the being defective more often. But mutual cooperation and fitness can be realized by this kind of word. Environment thrives. Actually, these two words appeared in this single personality trait description. So personality achievement with personal development in mind thriving in cooperative environment. So very balanced and toward cooperative behavior. Another interesting thing is that here, so caring and genuinely do not appear to be directly related to the successful defection. But also these two words appeared in the single this personality description, such as prioritize personal growth in recognition, genuinely caring for other feeling. Actually, this is a bit subtle and not clear tendency, but such an unclear personality trait might anyway result in the successful defection. Okay, let me summarize the talk. So we introduced an evolutionary model of personality traits related to the cooperative behavior using the genotype-phenotype mapping and mutation process based on the large language model. The evolutionary process exhibits the emergence of diverse and higher level representation of personality trait. So this is actually the use of the minimal use of the LLMs. So there are ongoing future work. So we want to use the more recent sophisticated language model and some detailed analysis of the properties of evolved personality. It will be interesting. So we can pick up the evolved and survival agent to ask some question to obtain some, for example, big 5 personality traits. And the benefit of this approach is to be able to conduct various obtain various behavioral patterns from a single personality trait gene. So the experiment with a different type of environment would be a future direction. And also we might be able to assume that evolution of a human versus AI agent. There are several directions. Okay, thank you very much for kind attention.